There we go. Glad I figured out how to do that, because before I had to shut the whole thing off and restart it.
I understand how to find equilibrium resistance, but B and C, I don't.
Okay. Thank you. Let's see how well this marker works. Oh, much better than I expected. And I'll just use different numbers here. Oh, it's so nice that the resistance I picked is different than the subscript. So why don't we just make that 1, 2, 3, 5, and 6. And so, same problem, different numbers. And the question is, if R2, which in this case is 2 ohms, is a light bulb and blows, if the current gets above 1.5 amps, maximum voltage, and then we switch it over to R5. All right, so whatever's flowing out of the power supply is going to flow across 2. Not the same for over here, but for here it is true. So for part B, if you know the equivalent resistance, then we can find the current flowing out of the power supply. And so the equivalent resistance, let's just run through it. Parallel or series?
This is resistors, that's.
Yes, these are all resistors. Okay.
That's parallel. So
If they were capacitors, what would it be?
it would be 1/5 plus 1/6 equals some number, and then you have to do raised to the -4.
Yeah, but the second up question relate, I'm gonna try proper English syntax now. You said, are those resistors, as if that would have a bearing about whether these were parallel or series.
Oh,
And then I said, if they were capacitors, would they be parallel or series?
oh, still parallel.
Yep, okay. So however, to add them, 1/5 plus 1/6 is 1 over my equivalent resistance.
Wait, no, that's for, oh, never mind. Oh,
All right. So we end up with 11/30. So this combines to give us 30/11ths. And then the rest is, I now have a series here, and so it becomes 6 and 30/11ths. Which is 66, 96/11ths ohms. And I know I need to limit the current to 1.5 amps, so 1.5 amps across here times 96/11ths, and you get the voltage.
and that's the voltage for,
That is the maximum voltage the power supply can be so that this does not blow. Because in the problem it states there's a maximum 1.5 amp. Above 1.5 amps, this will blow.
okay, so we found equivalent resistance.
All right. And again, so this allows us to find the current flowing out of the power supply. And in this case, what's coming out of the power supply is the same as what flows across that. So that's why I have 1.5 amps here times the equivalent resistance.
I thought that was given to us, the number of amps coming out.
Yeah, but what the voltage was not.
Okay.
We were trying to find this. And you multiply those. And you get
Some,
144/11ths. Or something.
So is the 9611s the maximum voltage or the 14411s?
The 14411s is the maximum voltage, the 9611s is the equivalent resistance.
13.0909090909.
Okay. Now the second part's a little bit more difficult. In fact, other questions on this before we do part C?
I think this is a master set question.
Yeah, the last, not the next to last problem?
Second to last one.
Master's at 21. Problem 3? 5. Okay. In the second part, this is now the light bulb. And the maximum current across here is 1.5 amps. So we need to figure out how much power or how much current has to flow out of here for this to be 1.5.
Well, it seems a lot harder than just
Not a whole lot. Except for that whole writing thing. That is. Oop, that does not go in there.
I'm sure they could recycle some.
Yeah, the trouble is, with the recycling is we were just allowing all sorts of stuff to get thrown into recycling, and then it gets shipped over to China. And at least this is the, from what I've been told from someone who runs a recycling center in Atlanta. And then China said, there's too much stuff in here that we can't recycle, so you know what, until you clean up your mess, we're not taking it anymore. So, there's been more of a crackdown on
What you can and can't recycle.
Yeah. All right, so this is 1.5 amperes. Well, I know since those are in parallel, that the voltage drop across here has to be same as the voltage drop across there. Well, my voltage drop across here is 7.5 volts. Therefore, across here is 7.5 volts. Well, if I know the voltage and I know the resistance, I can find the current. Again, Ohm's law. So 7.5 is equal to I times 6. I 7.5 divided by 6, which is 1.25. I think.
Yes.
So what I have here is that I've got 1.25 amps flowing down the right-hand path. I have 1.5 amps flowing down the central path. So the total current coming out of the power supply, well, current in equals current out. So I've got 1.75 amps. Sorry, try that one again. 2.75 amps. So now I know what the current that's going to be flowing out, maximum current flowing out of the power supply. Well, I plug into this equation, except instead of 1.5 here, I plug in 2.75. And I get some new magical number.
Wait, so the way you got 2.75 was by doing or finding the current from resistor 5 and resistor 6?
Yeah, the current flowing across each.
Yep. And then you added that up to get you what the current was before it splits.
Correct.
And then to find, what are we doing now? We're trying to find.
We're trying to find the maximum voltage here. So this is the maximum current coming out of the power supply. I know my equivalent resistance is 9611ths. And so I multiply my current coming out of the power supply times the equivalent resistance to get the maximum voltage.
Oh, so, okay, that was, how do we know that is the maximum voltage? The 2.75? Or
That's the maximum current.
How do you know that?
Well, I know that my maximum current across here is 1.5 amperes.
Okay.
And because that's the problem.
Right.
And I know because those are in parallel, that my voltage drop between these 2 points is 7.5 volts.
Right.
Because it's 7.5 going this way, current times resistance. So it has to be the 7.5 going that way.
Okay.
Because the voltage drop is the same, is 7.5 going across this way, I can find the current that would produce that.
Oh,
And so now I have the 2 currents coming out of the junction, therefore I can figure out the current flowing into the junction.
and the current isn't, the maximum current is affected by those two resistors, the number 2 and 3? Like, is it gonna be changed from where it's exiting?
Oh, over here,
Well, no, like, starting from the battery,
right?
going across those resistor 2 and 3, is that gonna affect the current?
No, it won't affect the current. If that's still 1.5, that's 5 ohms, that's 6 ohms, that's 1.5 amps max here. This is still gonna be 2.75 amps.
Okay.
Where that 2, 3, and the 1 show up is in the equivalent resistance. So it will affect the voltage, given the way that the property's been set up.
And it is 24.
Delta V max. Part C.
And then 13, the way we got 13.09 volts was part B,
Yes.
and then finding the equivalent resistance was part A.
Yes.
There's the match, so. Nice. Do you know what the warm-up questions on the test are gonna look like? Like, are they gonna be like the conceptual questions on the master set?
I don't know yet.
Yes.
I don't wanna spoil the fun for both of us.
Fair. For both of us.
I'm gonna go to ChatGPT and just type in
Physics test.
physics test circuits, DC circuits. Actually, I did that, I haven't used them yet, but I did that. It had a pattern of 10 multiple choice followed by, is it 5 short answers, something like that? It was boring. Not that I'm saying that the test tomorrow is gonna be any more exciting, but
Oh, sure.
two markers that work. Other questions?
This is kind of related to the master set. In number 4, it asks like where you would attach
Uh-huh.
voltmeter and how do you pronounce it? I'm just mostly confused about like if you switch up which end of the probe goes where, how it changes the reading.
If you put assuming you're putting in the multimeter correctly, the ammeter or the voltmeter, if you have the leads flipped, you'll just get a negative of what you had the other way.
Okay.
No, it's not a. Yeah, and in the lab that we did last week, it was just a matter of ignoring the negative sign. Is that the question that you're asking?
Yeah.
Okay.
I had a question. For the lab last week, is it due tomorrow?
No,
Okay.
it would be due
Tuesday we get back from.
officially, yeah. If you want that hanging over your head. You could hand it in early and just laugh at all the other people who haven't finished it yet.
Well.
Or you could be like me as a high school student and probably as an adult too, and just wait till the last moment.
Dr. Fox method being.
Yeah.
I still remember writing in my notes from last semester. It was like on one of the equations, on one of the I think it was on a lab. I just said Dr. Fox said it. That's my explanation. Because it was like, okay, write this out, explain why you did such, how does this work? I was like, yep, this is the answer. I did the calculation. Don't think I messed up. And Dr. Fox said it. I only lost 1 point on that problem.
All right. Other questions?
Yeah, for number 6 on the master set, do you just guess and check when you make the circuit?
Because you're trying to limit the current within a certain range.
Yeah.
Yeah, the part that I hesitate on is the guess part. You know, I know that if I add a resistor in parallel, I'm gonna reduce the resistance and increase the current. If I add it in series, I'm going to make a higher resistance. So they're an educated guess.
Yeah.
There are multiple tries. Unless you get lucky the first time.
And would the kid's toy be in the problem like its own resistor?
Yes.
Okay. And you just have to have the right amount of current going through the toy, not
Yeah,
the whole circuit?
correct. Some people, the biggest mistake I see is people putting the toy in a parallel path and then using that to figure out the current flowing out of the power supply, which is not what's going across the toy. So just be wary of that. Actually, the bigger mistake is people get partway through it and go, you know what, I don't have time to figure out anymore, so I'll get whatever I can get for this, even though the toy's gonna burn up or not work. Because those people hate children. Yes?
And how do light bulbs work as resistors?
They are, so when you're losing energy going across a bulb, there are a couple things that happen. One, I'm talking the incandescent bulbs. The filament, because you're losing energy in the form of mostly heat, and the other thing that it does is to start to light up as it gets hot. And so we use the light part for the purpose, and then the heat, I guess, for the purpose of an easy bake oven. But it works because there is enough resistance in order for it to generate heat and light.
And that'll just take the place of one resistor, the light bulb?
Yeah, the light bulb. It is a resistor.
Okay.
It's a rather flimsy resistor because I can take the resistors you were using, drop them, and still use them, but the light bulb's probably not.
And how do you figure out the lifetime of the battery?
Lifetime has a certain number of charges, so the greater the current coming out of the battery, the faster you're losing charge, and so the greater the current, the shorter the lifetime. So if I have resistors in series, then the current's dropping, so the battery will last longer.
I misread it, but I thought it was asking for the exact number, not who did.
Oh, no, I think that was just is the lifetime increase and decrease
It is.
or something like that, stays the same. Yeah, there's not enough information at the exact lifetime. And then there's certain realities you could throw into it, which I did not, such as, it's been sitting in your drawer for a year. How much charge is left? Yes, Ethan.
Other questions?